Hello guys. So in this video we will be talking about the one of the most common data type used in Java, which is the string. We'll see some memory concepts and some concepts associated with the performance of this string. Okay. So let's quickly introduce what is a string and what is so special about string. So string is, as I've already told, is one of the most common data type used in Java. Few concepts or related to string. One is it's immutable. I'm assuming you all must have heard about it. What does it mean by immutable? Is just once an string object is created, you cannot change it. And if you try to change it, it will create a new object. Okay, and we'll see it with an example. And since you cannot change it, this makes them thread safe. And okay, and another is key to optimize the string objects. JVM uses a special concept called string pool. And what it does is it reuses the string literals so as it does not have to create the same literal again and again. And we'll see this with example also. Okay. So first let's see what is a string pool. Pool is a special region in heap where string literals are stored. Okay. And why do we use pool? Because pool is used so that literals are reused instead of creating new objects every time. Okay. So let's see an example. So Okay, so let's say there's a string s1 equals to abc. So what it does, it will create a literal abc in the pool area and will not create anything in the heap. Okay, now there is a property of pool. If any new literal it wants to, if any new literal needs to be created, it first check whether the same literal is already exist in pool or not. And if it already exists, it does not create the new literal. Okay, so when this line executes, string s2 equals to abc and abc literal already exists in pool, it just does not create the new literal and simply s2 will point to abc. Okay, and if we do s1 double equals to s2, so so there are two ways of comparing string in Java. One is double equals to, one is equals. Double equals to check the references or the memory location of the actual data. So S1 and S2 are, as you can see, both different reference, but they both pointing towards the same literal in the pool, hence the same memory location, and that's why this would be true. Okay, and this is one of the most common interview question you will see in for string. Okay, now heap memory. Whenever these strings are created using a new keyword, like any other object, if you can create a string simple as string s equals to new string also, and if we use new keyword, then they are created in heap. Okay, so example would be, so string s1 equals to abc, this would be in pool. String s2 equals to new string of abc, this would be in heap. Okay, now if we do s1 double equals to s2, this would be false because s1 is pointing towards the pool memory location and s2 is pointing towards the memory location of heap. So both are different, hence it would be false. But if we do s1 dot equals s2, this is the true because dot equals function checks the content of the object, and in this case content of the string, and both the content are abc and hence equal. That's why this is true. Okay, as I've already told, there are two comparison methods: double equals to, which compares reference to check if two objects point to same memory location, and dot equals, it compares the content of the two objects. Okay, now let's see one more example of pool. So string s1 equals to abc, s2 equals to abc. So first line will create a new literal in pool, which is abc. Second line will point to that only. We have already discussed this. So one literal would be created in pool. S1 and S2 would reference to the same literal in pool. Nothing is created in heap. Now we have seen in one of the older video that the local variables are stored in stack, and now we have seen two more things: heap and pool. So there must be the question arising in your mind about where does those references are getting stored. So these references are the local variables, right? So these local variables would be stored in stack. So these references are stored in stack. Okay, and this would be the example for heap. So s1 equals to new string. This is the first line. So first line creates an object in heap. Okay, one more thing is, whenever you create an object in heap, s1 equals to new string of abc, this will create an object in heap and also adds a literal in pool if the literal is not added. Okay, so this would create an object in pool and add a literal in pool. Okay, now string s2. Okay, so there's one more function intern. What does it does? It simply creates a literal in pool for that string literal if it does not exist. Okay, so what does it check? S1 dot intern. It will check what is the value of S1 ABC. So if for ABC the pool literal is not created, then it will create. Else it will point towards that. Okay, so S2 is equals to S1 dot intern will do nothing. Simply S2 will now points towards the pool reference of ABC. S3 equals to ABC. Again, third line, S3 will point towards the literal in pool. Okay. Now, if these three lines are clear, then these comparisons should be very easy for you. S1 equals to S2. This is false because S1 reference is pointing towards the memory location of heap, while S2 is pointing towards the memory location of heap pool. Okay. S2 equals to S3. This would be true because S2 and S3 both are pointing towards the memory location of the pool. Okay. Now, this is the combined example of where everything is getting stored in the way you are creating. So, string S1 equals to ABC. This is creating a literal in the pool area. S2 equals to pclear, also creating a literal in the pool area. Now, when you do string S3 equals to ABC, it's not creating any new literal. It's pointing towards the already existing literal here. Okay. String S4 equals to new ABC. This creates a object in heap, and since ABC is already created in pool, it will do nothing. String S5 equals to PQR. This would point toward, this will create a new object in heap called PQR. Okay, and new string ABC dot intern. So this would create a literal in a pool, but it's already exists. So S6 will points towards the ABC. So if I do S1 equals to S3 will be true. If I do S1 equals to S6 again will be true, and it will be very easy for you now to understand why how the comparisons are actually getting work. Okay. Now one thing about performance majorly is we have seen that string is immutable. So whenever we do a plus operation or a concate operation or any other operation on a string, it creates a new object in heap. And every time you create a new object in heap, it the associated with memory with it, their new objects are creating in heap. So this is a overhead. Okay, and assume a code like when there's a loop of 1,000 is running and you are creating the objects inside loop, so the thousands objects are getting created and one object is in created in each iteration. So this code is not optimized. Okay, and how can we optimize it then? We can use another class called string builder. So it does not create new object every time, it modifies it. Okay, so basically there are two classes, and this is also one of the common question ki what is string builder, what is string buffer. Okay, so prior to Java 1.4 or with till Java 1.4, there's only two classes, string and string buffer. And whenever there is such a case of performance, ideally string buffer was getting used. But there is a problem with string buffer also. It is thread safe. So in a multi-threaded environment, for a multi-threaded environment, thread safety is needed. But since string is a highly used data type, majority of the cases when you use, there is no issue of multi-threading. Hence, thread safety is an overhead. So synchronization is an overhead. Hence, it causes the performance issues. So with Java 1.5, string builder class is introduced so that for the cases where thread safety is not needed, you can use string builder. And if you run those two codes, the upper one and the lower one, you will see a definitely improvement in the below one. Okay, and strings in the pools are garbage collected when no reference exists. Since objects, I'm assuming this is a basic concept of garbage collection. We'll create a video on this later, but I'm assuming I'll tell you in brief how is garbage collection work. We create the objects in heap, and as soon as the reference to those objects are destroyed, then those objects are eligible for garbage collection. So garbage collection runs via daemon thread inside Java, and it as soon as it runs, deletes it garbage collect the objects, meaning it deletes the object from the memory and free the memory. Okay, string in pools are not garbage collected, so because the literals in the pool are getting reused, hence they are not garbage collected. And string literal reduces memory overhead, like we've seen ki since the literals are reused and in the object memory in the memory object are getting created using new, and every time a new object is getting created. So do not use new every time. If your work is getting done by simple literals, then use those. Okay, that's it, guys. Thank you. If you guys feel any issues or if you have any doubts, please feel free to comment. I would definitely respond to them. Thank you.